enones. Okay? In this case, it's the carboxylic acid. We usually don't think of alkenes as being electrophiles, but when they're connected to carbonyls, they are, because we can push the electrons up into the carbonyl group. So remember the logic here. We've done our first 2-electron oxidation to introduce the double bond. Now we've set it up so we can introduce an oxygen into the molecule, and then probably you'd think, well, then the next step, we're going to then oxidize that oxygen to form the carbonyl. And that would then give you the second 2-electron oxidation. So we see water attacking fumarate to form a carbanion transition state. Okay? You can have it on the carbon, but realize that that's a resonance delocalized, right? So we have the negative charge on the carbon, alpha to a carboxylate group, so that can be resonance delocalized. It's going to then pick up a proton in the second step, okay? So that now we have L-malate. So essentially we're converting our double bond. All right? We're doing an addition reaction. We're going to add OH to one carbon, and we're going to add H to the other. All right. So again, the whole point of these last 3 steps are to do a 4-electron oxidation and add a carbonyl. And the oxygen is coming from water. All right? So notice that it's the same enzyme carrying this out. When you look at this molecule, when you think about alpha-beta unsaturated carbonyl compounds, just remember that when you look at a carbonyl compound, we always say that the carbon is electrophilic, and then the oxygen that it's double bonded to is electron-rich. Well, we see that pattern repeat itself as we work through the molecule. So let's just focus on this one here, right? So we would say the oxygen is electron-rich, carbon is electron-poor. And if you were to look at an electrostatic diagram, okay, we're going to kind of ignore this, you would see this is electron-rich and this is electron-poor. We call it Umplong reactivity. Essentially, it kind of repeats itself, right? Electron-rich, electron-poor, electron-rich, electron-poor. So it renders it electrophilic. And we also have an electron sink to donate those electrons into. All right? So that's fumarase. Fumarase is also